Good morning, friends. Today we are going to discuss hydraulic pneumatic subject, unit number 4, hydraulic circuit and contamination controls, lecture number 2. See here, learning objective to understand different types of hydraulic circuit and their construction and operation. Objectives of this lecture to understand different types of hydraulic circuit and their construction and operation. Outcomes at the end of the session, student can understand, know the different type of hydraulic circuit and their construction and operations. Different hydraulic circuit: simple reciprocating, single acting, double acting, regenerative hydraulic circuit, speed control hydraulic circuit, different flow circuit, meter in, meter out, grade off, sequencing circuit, synchronization of circuit, traverse and feed hydraulic circuit, transverse and feed hydraulic circuit, automatic reciprocating hydraulic circuit, fail-safe hydraulic circuit, counterbalance hydraulic circuit, actuator rocking unloading circuit, motor braking circuit, speed control of hydraulic circuit, meter in, meter out, and grade off. In previous lecture, we have seen simple reciprocating circuit, single acting and double acting, regenerative circuit, regenerative hydraulic circuit. We have seen in previous lecture. Today, we will going to discuss here speed control of hydraulic circuit, meter in, meter out, and grade off. So, speed control of hydraulic circuit. See here. In this circuit, our proper way, see, this is PRV, this is tank, pump, and now it goes to the second positions like that here. So pressure support from second position to the rod side, oil goes to the rod side, and piston side oil removes to the tank like that. This is complete circuit here. Speed control and hydraulic cylinder. See here, in this circuit, at the outlet of the cylinder, piston side oil cylinder, here flow control valve and check valve is pressed. From this, we have control the speed of the cylinder. This is piston rod. When the direction control valve is actuated, oil flow through the flow control valve to extend the cylinder. The extended plate of the cylinder depends on the setting of the flow control valve. In extension position, the speed of the piston depends on the flow control valve. When the direction control valve is deactivated into the spring offset mode, the cylinder retracts as the oil flows from cylinder to the oil tank through the check valve as well as the flow control valve. When the direction control valve is deactivated into its spring offset mode, the cylinder retracts as the oil flow from the cylinder to the oil tank through the check valve as well as the flow control valve. The extending speed of the cylinder depends on the setting of the flow control valve. When the direction control valve is deactivated into spring offset mode, the cylinder retracts as oil from the cylinder to the oil tank through the check valve as well as flow control valve. Analysis of extending speed of the control valve. The flow rate of the cylinder equal to pump flow rate minus the flow rate to the PRV. Means analysis, the flow rate of cylinder equal to pump flow rate minus pressure relief valve flow rate. The flow rate to the flow control valve FCV is governed by equation QFCV equal to CV upon under root of delta P upon Hg, So CV equal to under root of P1 minus P2 upon Hg. Delta P pressure drop across FCV, CV capacity coefficient of FCV, Sg specific gravity of oil, pressure P1, PRV setting, pressure P3, ingoing small friction pressure drop in drain line from rod end of the cylinder to the oil tank. Pressure P2 can be obtained by summing force on the hydraulic cylinder. P2 A piston equal to F rod or P2 F rod upon A piston. The extending period of the cylinder can be represented as a function of the flow rate through the flow control valve as follows. Velocity cylinder Q cylinder upon A piston equal to QFCV upon A piston. Varying the setting of the flow control valve and thus the value of CV, the desired extending speed of the cylinder can be achieved. V cylinder CV upon A piston, PRV minus F rod upon A piston, Hg. Speed control of hydraulic motor. See, this is speed control of hydraulic motor. Like that. Here, flow control valve. This is speed control of hydraulic motor. In this way, we have controlled the speed of the hydraulic motor like that. Here, flow control valve, this is check valve, supply of the oil by control by this flow control valve like that. So in this spring centered position at tandem four-way valve, the motor is hydraulic lock. When the four-way valve is actuated into the left envelope, the motor rotates in one direction. Its speed can be varied by adjusting the setting of the throttle of flow control valve. In this way, the speed can be infinitely varied as the excess oil goes through the pressure relief valve. When the four-way valve is deactivated, the motor stops suddenly and becomes locked. When the right envelope of the four-way valve is in operation, the motor turns in opposite direction. The pressure relief valve provides overload protection if, for the example, the motor experiences an extensive torque load. Like that. Closed circuit meter in and meter out bread off. See, flow circuit of meter in, meter out. At the meter in circuit, flow control valve at the piston side and meter out at the flow control valve at the rod side, outlet of the rod side. So in this way, this is meter in, this is meter out circuit. Bread off circuit and the bread off circuit flow control valve at the PRV. See, this is speed control of hydraulic motor. In this way, control the speed of the pistons. This is meter in, flow control valve at the inlet, meter out, flow control valve at the outlet of the cylinder, and in bread off circuit, flow control valve at the join to the PRV. In this way, we have control the speed of the circuit. This is meter in circuit. See operation of meter in circuit. So this is in second position. I go to here like that. DCV piston goes to the left hand side, and here this is A to T, oil returns to tank. Yeah, FC normal position. This is retraction. This is normal position at retraction. In flow in controlled. In that case, in flow in control. Like that. Flow control position. Same. In first position, flow control. unrestricted flow, in control. Meter out circuit, unrestricted flow, like that. Here, flow control at outlet. Outflow is control. Outflow is control. Inflow is control. Meter in circuit. Inflow is control. Outflow is control. Means outlet extension of the piston control. Bread off circuit. Compared to meter in and meter out circuit, a bread off circuit is less commonly used. Figures show a bread off circuit used for stroke control. Compared to meter in and meter out circuit, a bread off circuit is less commonly used. Figure shows bread off circuit used for stroke control. It goes to the P to B from like that. Compare the meter and meter out circuit. A bread off circuit is commonly used because show the bread off circuit used for stroke control. Here, control the stroke and flow control or control the here. This is stroke like that. See here, this is flow control or at the outlet. Bread of forward direction, bread of both directions like that. Bread of circuit in this type of flow control, an additional line is run through flow control or back to the tank. To slow down the actuator, some of the flow is bred off through the flow control wall into the tank before it reaches the actuator. This type of flow into the actuator, thereby reducing the speed of the extended stroke. The main difference between a bread off circuit and a meter in and meter out circuit is that in a bread off circuit, opening the flow control wall decrease the speed of the actuator, whereas in case of meter in and meter out circuit, it is the other way around, that is control the actuator speed. So besides generating the less heat, a bread off circuit can also be more economical than a meter in and meter out circuit. For instance, if flow rate of 100 GPM had to be reduced 90 GPM, 90 GPM flow control wall would be needed in meter in circuit, and depending on size of the cylinder, approximately a 70 GPM flow control in meter out circuit, whereas in a bread off circuit, a 10 GPM flow control could be used. Even with this apparent advantage, a bread off circuit is not very popular flow control circuit. This is because the flow control in a bread off arrangement only indirectly control the speed of the actuator. It can precisely meter flow to the tank, but if leakage through various system components increase, actuator speed will decrease. A bread off circuit can be used in any application where precise flow regulation is not required and where the load offers a constant resistance, as in reciprocating grinding, table, awning operation, and vertical lifting load. Sequencing hydraulic circuit, sequencing circuit, cylinder 2, AP, BT. This is sequencing circuit. In this at middle position, all port is closed. Yeah, second cylinder power sequencing. Yeah, PRV at 100 bar. See, this is sequencing circuit like that. So parallel configuration. See, after pressing ref button, what happened to the circuit? See, this is after pressing ref button. This this oil goes to the P to A from like that in this direction. Parallel configuration P to A like that. Then to this PRV set external drain at punching cylinder. But here the pressure applied, here some pressure range selected for this PRV 350 bar. After 350 bar, this oil returns to go to like that this cylinder, and this cylinder 2 punching cylinder is activated. This is clamping cylinder. First we clamp the workpiece. After completion of the extension of this clamping cylinder, the pressure increase continue. After increasing pressure PRV 350 bar, above that pressure increase continue. This port is open. This oil goes to the like that. Here, after this PRV open this side, and oil goes to the piston side of the second punching cylinder. Then this cylinder extend and punch the workpiece. This is sequencing cylinder. Means firstly extend this cylinder, complete the work, hold the workpiece. After that extending, this cylinder is stop here, piston stop here. So here continuous supply, increase pressure, pressure increase up to 350 bar. Then 350 bar, after increasing pressure, this valve is open above 350 bar. Then this cylinder is open like that. So this is a sequencing cylinder. Parallel configurations. After pressing ref button, what happened in the circuit? We have seen or discussed. In first position, I have discussed with you. Pump flow is going to cylinder 1, not cylinder 2, as because there is sequence valve in the line. Sequence valve is closed 1 and sequence open only with the set pressure at sequence valve which is in the line pressure. This is sequence valve set up to 50 bar. After cylinder 1 is complete extend and hold the workpiece, then pressure, then workpiece, then pressure start building in the line and make the pressure in the line more than the pressure setting at the sequence valve. Immediately sequence valve open and allow the flow to passes through it, and then cylinder 2, and it start moving downward to the punch of the workpiece. See, at first position, oil goes to P to A through this cylinder side, piston side. These pistons extend the workpiece, we extend the cylinder, sorry, extend the rod in right side to hold the workpiece. After completion of the extension, here increase the pressure up to 50 bar. Then this sequence valve set the pressure range 50 bar. After 50 increasing pressure at 50 bar, because continuous supply of oil by pump, here this sequence valve is open and transfer the oil to piston side of the second punching cylinder, and this cylinder punch to the on the workpiece. In this way, this sequencing or sequencing circuit operating in first position like that. Parallel configuration, cylinder to compress the workpiece and complete the task. Pressure start building in the line 4/3 dCV, change its position to right position as. So cross configuration, in case of cross configuration, Once right hand side of the receive push button is pressed, then flow divert to both the cylinder at rod end. So both the cylinder retract quickly to the initial position. Note the fluid present in the head side of the cylinder 1 is passed to tank to the return line, while the fluid present in the head side of the cylinder second is bypassed through NRV of sequence valve. So see here at the cross connection, here I apply the pressure here flow divert to both the cylinder at rod end, so both the cylinder retract quickly to the initial position. Both sides flow the oil, therefore both cylinder retract to take initial position. The fluid present in the head side of the cylinder 1 is passed to tank to the return to line. In this way, this fluid return to the line, and while the fluid present in the head side of the cylinder 2 is bypassed through NRV. Here, this side oil in this tank, corrected in this tank, like that. Synchronization hydraulic circuit. This is cylinder hook in parallel will not operated in synchronization. If the two cylinders are identical, it would be necessary for the load on the cylinder to be identical in order to them to extract synchronization. If the load are not exactly identical, the cylinder with the smaller load would be extend first because it would move at lower pressure level. It should be pointed out that no two cylinders are really identical. Different in packing friction will vary from cylinder to cylinder. Cylinder connected in series. See, this is our basic circuit. Here, our direction control valve. See this position at close position. We can see here. This is cylinder 1, this is cylinder 2, this is P1 at this side, P2 at this side, this is P2, this is P3. Because this P2 apply on here, this is cylinder connected in series. And extend this cylinder, F1, F2 force apply on there. So cylinder hook in series will operated in synchronization. So out cylinder in equal to Q in cylinder 2. So since Q equal to A, where A is the effective area through which fluid flow, we have A effective into V cylinder area of effective upon V into cylinder 2, AP1 minus AR1 into V1 equal to AP2 into V2. Since for synchronization, we have to desired result AP minus AR1 equal to AP2. Force analysis summing force on cylinder 1 need P1 AP1 equal to P2 into AP1 minus AR1 equal to F1. So repeating this force summation of cylinder 2, we have P2 AP2 minus P3 AP2 minus AR2 equal to F2. Adding the preceding two equations together, noting that AP2 and AP1 minus AR1 and that P3 equal to 0 due to the drain line to the tank, we obtain the desired result P1 AP1 equal to F1 plus F2. In the question and answer here, please ask me any question, any doubt. Thank you. So today we have stopped here. Any doubt, any queries, please ask me.